Hi friends, it's Mrs. Kusalaba, and this video is for lesson 212 mixtures. I am actually out today. Miss Sudhakaran, if you're watching it for her class, will be out. She'll be back. I'll be back tomorrow. So we are going to talk about mixtures today, and hopefully this will be an easy lesson for you. We're going to shift away from chemical reactions, and we're actually going to talk about physically combining substances and what that looks like and what the process is. So today our goal is to be able to differentiate between the words element, compounds, and mixtures. So make sure you know what the difference between compounds and mixtures are. We'll look at lots of examples. Then at the end, we'll want you to read your ebook after I'm done with this video. And you can also go make a mixture at home to show somebody. So let's review the vocabulary real quickly. Let's look at the word elements. You remember elements are pure substances made of all the same type of atoms. And also remember when we talked 2 days ago about compounds that elements do not become compounds unless they have a chemical reaction that binds them together. And just as a vocabulary review, compounds are a special type of molecule that has different atoms in it. Not the same atoms, but different atoms in it. If they had the same type of atoms, that would just be an element, but if they, or called a molecule, but since they have, in this example, nitrogen and oxygen, they are called compounds. So you may remember from yesterday's class that once they have that chemical bond between them and they're sharing those electrons, those compounds cannot be separated by physical means. So we need to realize today, what does the word physical means mean? Just means we can't pull them apart physically. They would have to be separated with some other type of chemical reaction to get them apart again. All right, so poor little oxygen atoms there's like, wait, what? Can't be separated by physical means? Did that ant use super glue? All right, but sorry, little oxygen. Once that happens and you get bonded to somebody else, can't just be plucked apart. Have to go through a chemical reaction if you want to separate. All right, but the good old professor comes in and says, relax, nitrogen oxide. Let me show you an example of another compound, water. And he goes on to say, have you ever tried to separate the tiny H's and the O's out of water? Can't do it? Well, that's because of all those chemical bonds. Well, the good news is we have different types of substances that when we put them together, we can actually pull the pieces apart. And that vocabulary word that we're learning today, guys, is the word mixtures. These are substances that can be separated with physical means, like sifting the pieces apart or just plucking them out. So let's take a look at what mixtures are, because that's our vocabulary key focus today. So a mixture is different than a compound or a molecule because a mixture is a substance in which two or more substances are mixed but not joined with chemical bonds, meaning that a chemical reaction did not take place. Sometimes examples of mixtures are really obvious, like Lucky Charms cereal, for example. You can see all the pieces and parts, and as a matter of fact, if you stuck your fingers in there, you could pull apart the marshmallows and all the little pieces. But that is an example of a mixture, guys, because you can physically separate, without doing a chemical reaction, all the pieces and parts of the mixture. So have you ever separated all those yummy marshmallows out and just eaten the marshmallows? I know I have. Okay, so this picking apart and pulling out the pieces is what we call physically separating. Doesn't take anything fancy in these cases to get this mixture to pull apart and go back to the original state that it was. So maybe in this example, all the marshmallows were in one container before they dumped them all in together. Well, we could literally pluck out the marshmallows and put them by themselves. So these marshmallows aren't chemically bonded to the pieces of cereal that are in this cereal bowl with it. Fruit salad is another example of a mixture. Think about it. Do you pick out just the pieces you want to eat at a picnic? I know I do. I know my kids do too. A mixture can contain any elements or any molecules in any amount. So just like this fruit salad, there could be a lot of grapes and maybe not so many strawberries. But that's okay. It's still called a mixture. Remember when we talked about compounds and molecules and the chemical formula thing? Those compounds and molecules always come in a specific formula, right? There's always a specific amount, but not the case with mixtures. It doesn't matter how many elements or how many molecules are present to be a mixture. You might also remember in a chemical reaction, you get a new substance, but that's not the case in a mixture. In a mixture, each little piece, no matter how small or how big that piece is going to retain its original properties. They can also be returned into their original form. For example, sand is a mixture of solids. The individual particles in sand do not change when they are mixed together, and they could be easily separated. The next vocab word that we have to know for this unit is the word solution. So let's take a look at what a solution is. Solutions are pretty cool because they don't look like a mixture, but they are a mixture. And I bet you guys are familiar with a bunch of solutions that you have or have had around your house. Here's a really yummy example. Have you ever made Kool-Aid or any drink mix where you actually add the sugar and the little packet? So the elements or compounds that are in that Kool-Aid packet will dissolve in another element or in a compound like water. And once that Kool-Aid packet or whatever substance you've added dissolves, the solution or the water with the Kool-Aid in it has the same properties throughout. And it even looks the same because the whole thing turns red in this picture, doesn't it? Vinegar is another example of a solution. Vinegar that we use for food is 5% acid and 95% water. The water and the acid do not separate. They stay together, but there's no chemical reaction happening. There's no new substance being formed. That's how we know it's a solution and not a compound. So if we could zoom in and look at the Kool-Aid molecules and look at the sugar molecules in the Kool-Aid and look at the water molecules, you would see that they're mixed together. It looks like from our naked eye when we're just looking at a glass of Kool-Aid, it looks like they're all joined together chemically, but they're actually not. They're just floating and they're all together. So you can see the individual water molecules in blue here on this picture and the little Kool-Aid sugar molecules in red. This is what it would look like if we could zoom in with a microscope and look at the little molecules floating around. They're not chemically combining, they're just mingling, as this little guy says. Wee, free to mingle. So remember, solutions look like they're bonded, but they really aren't. So think when you think of a solution, think Kool-Aid, think that vinegar, those are examples. Tea, anything that you add like a powder mix to, that's an example of a solution. Okay, so what are some other examples of solutions that you might know of? Pause the video and think about that for a second and then come back. Some other examples are air, seawater with the salt in it, that's a solution. Hot chocolate, when you add the little hot cocoa packet, iced tea, Coke, brass, and some other alloys that are metals that are mixed together, maybe. Those might be examples of some mixtures. If it can be separated without a chemical reaction happening, we're talking about a mixture or a solution, okay? All right, so let's talk real quickly about homogeneous and heterogeneous mixtures. You can tell by the little atoms that sometimes a mixture is going to blend really evenly and really smoothly. Maybe so smoothly that we don't even see the tiny pieces and parts because they're all blended up nicely. These are called homogeneous mixtures, the ones that are really blended. For example, air in this balloon, the steel molecules in here, the wine, or even rain. Those have uniform or even distributions of all the particles inside. But the ones that don't blend very easily and are called heterogeneous mixtures. These ones would be example the ice and water. They kind of all go to the top of the water, so they're not evenly distributed. Maybe the cereal and the milk. Maybe you have more cereal than milk. Maybe you have more marshmallows than the regular Lucky Charm pieces. I don't know. Oil and water is an example of a heterogeneous mixture. And even soil, because you have more pieces of different particles in the soil than others. And those are called heterogeneous mixtures. All right, so next we're going to do a quick learning check. Are all of these mixtures? Pause the video if you want to take a look and think about that before you move on. All right, hopefully you said yes. The Fruity Pebbles here, that's a mixture all mixed together. You could separate the pieces. The salt and the water, believe it or not, you could actually get the salt back out of the water. That is a mixture. Coca-Cola has sugar in it. You could actually get the sugar back out of it. It's just the sugar is floating around in there. And this trail mix definitely can pick out the pieces. So yes, all of those are mixtures. All right, which one of these though are considered solutions? Pause the video, think about that, and when you're ready, go ahead and hit the button to play. All right, hopefully you said salt water and Coke are solutions because they're so evenly mixed that it seems like they are chemically bonded, those pieces, but they are not. We can actually separate out the salt in the water and the sugar in the Coke. We could do that if we wanted. Okay, so hopefully you remember for your quiz today that mixtures can be physically separated. They are not chemically bonded with the chemical bonds, so they're not stuck. They can be pulled apart. So all mixtures can be separated into their individual elements or compounds. Is that true or false? And that's definitely a true statement. All mixtures can be separated into their individual elements or compounds or pieces and parts. All right, guys, so if you want to do a science lab at home, just create a mixture or have some cereal and show somebody at home what a mixture is and tell them how it's different than a chemical reaction that happens to make compounds and new molecules and new substances. Explain the difference to them between the mixtures and the compounds. There's also going to be a simulation that you can do in your lesson module. What are we on? 212 today. Okay, so if you need a summary page, there's a summary page. Just pause the video. You can take screenshots. You can take a look at the difference between a mixture and what a solution is. And the last thing I'm going to leave you with is this. You're going to read your ebook today. There's only 2 pages, and it's actually a short reading passage. The ebook is entitled The World of Elements and Their Properties. Make a mixture at home for someone. You could even show them anything you have at home that would be a mixture and give some examples to maybe younger siblings. Maybe you can make dinner tonight and make a mixture. I don't know. But practice making mixtures and complete your 212 daily quiz at 2 p.m. I'll be back tomorrow. Mr. Dockran, if you're in her class, should be back tomorrow. And that's it, guys. Have a great rest of your day.